Hi, friends. Today we are going to do something very interesting. So, what we're gonna do today is we are gonna have a simple AI uh, model, uh, which which we're gonna deploy on AWS EC2 as a Python web service. We are also gonna use Docker to create a Docker image of it. Uh, so this is going to be very interesting. So let's quickly go through the basic our classifier. We are using a KNN supervised class algorithm to classify a basic sklearn dataset called iris dataset. Some things about the iris dataset is that it has feature parameters that describe the petal length, sepal length of different types of flowers. I think there are 4 different categories in this. Uh, so once we have that data set, uh, we have this IPYNB file which I'm running on the Jupyter notebook. We import all the libraries like the sklearn, iris dataset, test train split library, and the k-neighbors classifier from sklearn and joblib. Basically, we want this library to be able to pickle the model, the generated model. So we load the iris dataset, then we split it into testing and training data, training and testing data in 70:30 ratio. Then we initialize the k-neighbors classifier uh, because the number of target variables is around 3. So half of it, square root of 3 is around 2. So we use that, and then we fit the model on the training data and the training targets. Then we have the trained model, and then we predict using the test data and find the accuracy, and also have some sample test data that we want to test and look at the outcomes. So let's run this. So here we can see that the predicted target variables have been printed. This is the basic uh, um, classifier model, and we are pickling it using joblib.dump, and we are using the name iris underscore knn dot pickle. You can use any name. Now what we do is we need to use this model to expose it as a web service. So what we're gonna do is we have a simple Python web service framework called Bottle. We are using it, and we have the we have a basic project, and in the source folder we have added the pickled model file, and then we have the basic bottle web service class. We initialize the bottle web service, we import all the necessary basic libraries, and then uh, any configuration in a Python web service can be loaded using the application.properties file. uh, for Docker setup, it takes the relative context, and for you, if you're running it locally on the Mac, the Python class locally without any dockerization or anything, then you can use the actual path. So now we have a basic get call which checks the health of the application, uh, something like this. So it clicks OK. This is the end product, but we are not at there. So let's go back to our application. We load the pickled model. We load the iris data, and this is the post web service REST method that will cater, cater to the RESTful post call. And what it is pretty much doing is it uses the model to predict the uh, target species category. So once it predicts it, it will use the iris datasets target names to output the target names. And then basically it uses a wrapper HTTP response to wrap the target name into a JSON, and it returns it to the front end so that the end user can use it in his code properly in a front end application. So pretty much this is what we have. Some little bit of logging, and then in the uh, main method we can set the log levels. We serve up the bottle app, and at port 8080. Now let's go to the important thing, which does all the magic. We have a Docker file. I think you guys know pretty much know what a Docker file does. It creates it downloads images, and it can create images of operating systems like Red Hat. Here I'm using something from qa.io, Curios Hypercube, which is a Red Hat image. Basically what I do is I download the image, Red Hat image, and then I update the basic software, and then install Python and install um, pip, upgrade pip, and copy all the content in the source folder into the a new folder called src in the Docker image. Now then it installs Boto. We don't need Boto here. We will need Boto if we want to do put it in a Lambda framework. In a different video I'll also show you how to do a Lambda framework. And then we install Bottle, we install Waitress, and then PyYAML, if we want to parse the proper YAML files, we use it. Otherwise, we don't want to use it. URL lib for various URL, I mean REST API based item to parse the um, request, and then we have a Python date util for any logging using dates and formatting dates, etc. We also install scikit-learn because we need the iris dataset. We use a basic Docker user who would run this particular Docker application. We use the user, and then the entry point would be we are using Python to run this particular Python class at port 8080, and we are exposing 8080 on the Docker application. Now we have the basic setup ready. Like tomorrow, if we want to export it to a particular ECR registry, we can also do that like this in a makefile. Build a Docker and export it to a ECR, and then within the EC2 you can download it using the pulling it from the Docker ECR image repository. That we are not doing that here. Any particular environment specific properties can be loaded in the application.properties file. Right now we don't have anything. We just put the log level to debug. Now this is the basic application. Now what we are going to do is we are going to build this application. Yeah, let's see where we are present working. Yeah, we have I think we already spun up a Docker image, so we are going to delete that. Now what we're going to do is we're going to build the Docker image. This is going to take a while. In the meantime, I'll show you something where I have created a EC2 instance. This is my basic EC2 instance. I'm running on the free tier T2 instance, and I have set up the network security properties as well. Uh, Basically what I'm saying is these are the default ones. HTTPS is available on 443, HTTP on 80, that's the range. And then we have a custom property, a custom inbound rule where we saying that 8080 needs to be enabled. So that will allow 8080 to be opened up. Otherwise we'll need to have a load balancer or API manager that will get the traffic into the EC2. Right now we are accessing it directly. So I think this is the way we are going to do it. So this is one thing. We are going to access it through this particular uh, IPv4 public domain name, and we'll use the corresponding port. In our application we would be using the port level would be at 8080. That is where we are exposing the Docker images Python API is at 8080. So we are going to use the same port. So let's go back and see if the image is being created. Now we have already we have an image, and I think it is creating the uh, container from the image. So we have the Corios image, and then it is creating the container. It creates a container when we run the Docker command. So let's run the Docker container. So now let's go to our to test. Let's see if the application is working. Okay. For our convenience, I already set it up here. So let's test it whether the web service is working. So now we are making a simple post call with some feature parameters, and it should return the output, which is the target flower, which is Virginica. So our web service is working fine. Now what is left is we need to upload it into the EC2. Now the way we are going to do it is we are going to put our code in a Git repo. I have already put it in a Git repo. See, if you look at this, this is my Git repo, and my code is already there in Git repo. I need to install Git on the EC2 instance. I am going to new window, and for this I have a PEM file from my EC2. So I need to go to the location of my PEM file. So there's my PEM file. So I'm going to restrict the permissions of the PEM file to myself, which is a good practice, best practice, so that no other user on my Mac will be able to access it. This is some basic best practice. So then we are going to log into our EC2 into using the PEM file. Yeah, I'm now logged into my EC2 instance. Now I have already installed Git there. So if you want, you can go ahead and install Git. Uh, I have already installed Docker as well on my EC2. You can use this command to install sudo yum install Docker. If you want to install Git, you can use sudo yum install Git. So let me just double check that. So if I say Git, I have Git. Let me remove this already checked out repository, and let me kill the Docker containers and images that it has. So I'll have to stop the container first. So first I will execute. So there is a container, then I'm gonna stop the container. So that will stop the container. Once the container is like an instance and image is like a template, so we'll stop the container. Then we can remove the containers. It will remove all the containers, this command. The next command will remove the images. So let's do that as well. Remove all the images. Now we'll build a brand new Docker. First we'll need to check out the code using the git clone command. The git clone command, if you are not familiar, it will just create a clone of the repository, copy of the repository in your local machine. I think it already downloaded this. We go into the Iris Docker where the Docker file is there. Now we'll build the Docker image. So I'm running pretty much the same commands that I ran on my Mac locally on the EC2 machine. So this is one way of doing it. The other way is you could you could get a dump of the Docker image that you uh, put in the ECR registry, which is a Docker image registry basically. From there you can download it. There is a command for it, and you can once you download it, the image pretty much you don't need to build on the EC2 at that point of time. Generally, enterprise level applications, they follow that type of architecture where they download the Docker image from the ECR repository. This is basically a best practice. Like before, this is going to take a while. So in the meantime, we'll just go through our EC2. I have shown you the inbound rules, outbound rules. Pretty much I have allowed traffic from everywhere. This particular notation means all the traffic, wildcard, all the traffic is allowed. Let's go back to the EC2 and see this. See again, if I go with ECR, that is not a free tier, so I am not going with ECR at this point. And you can do a lot of things with EC2. I think they also have auto scaling. You can set up load balancers. You can set up. You can attach it to a auto scaling group as well, which means you directly have access to auto scaling using EC2. If the load increases, it automatically has another EC2 instance with your application deployed, and it will spin it up, and your traffic is diverted to that as the need, as and when needed. So it's a very good thing that they have all this set up. So now let's just go back and see if the image is built. Yeah, the Docker image is built. Now we just have to run Docker at port 8080. Yeah, now looks like our Docker image is running. Now let's check Docker images. So as you can see, we have the image there, and I think we can list the containers as well. As we mentioned earlier, image is the like a template and container is like a instance. So container is like a instance. This is the container that is serving the content. So it was created 37 seconds ago, and it is available from any inbound port through 8080, and it is serving to 8080 for the application. The image name is there. This is the container ID. So this is, so our application is up and running. Now we are gonna check whether our web application, web service can handle any post request. So now let's go clean up this slate and let's check. See, so now this is serving the response in a properly formatted JSON content. So I think we have learned a lot of important things. They are basic things, but we have learned very important things today about how do we Dockerize a Python web service and then transport it onto a EC2 and run it in a very elegant fashion. Uh, we can also install it in Kubernetes using ECS or plain old Kubernetes, which will help you create clusters in different regions. A cluster can contain multiple nodes, and each node need not have the same software. It can have different web applications. Basically, it's a more fail-safe distributed way of handling your application. For example, if a cluster is down in one place, it will be available in some other place. So that is the kind of flexibility that clustering provides. Uh, we can do that as well, but it's we are, on the free tier I think that is not available, but pretty much the basics are same. So I think today we have this is what we have. Thank you for being patient, and you could subscribe to my YouTube channel